So first, I would like to say that I'm honored to be present here, and I thank all the organizers to invite us. So just a word on Artelis. Artelis provides major European companies of the power industry with decision support tools on topics like production plan optimization, risk management, portfolio management, and long-term optimization. And we are working for energy producer, EDF, GDF, for transmission system operators, regulators. So, and I would like to present you a European project we set up for cities. It's financed by the European Commission. It's a research project, and we are working with Bologna and Cesena, two Italian cities, with 400,000 inhabitants and 100,000 inhabitants for Cesena. And the goal of the project is to design decision support tools to help local authorities to optimize their energy investments. So Bologna and Cesena, they are quite good at European standards. They are they emit 6 tons of CO2 per capita and per year. That's quite low for European standards. But they are already involved in a sustainable energy action plan. That is to say, they are plan a lot of projects on energy efficiency, cogeneration, PV, and public transport. And they plan to decrease their CO2 emission by 20% by 2020. So, and the goal of the project is first to monitor their actions. That is to say, given the advancement of the project, what are the impacts? And we are collecting some aggregated consumption measures, and we try to analyze them and assess what are the impacts of these actions. So the first goal is to be able to help them to monitor the impact of this plan. The second goal is a decision support tool, that is to say, to help them to choose between different solutions. For instance, in Cesena, there's a big district heating network. There's a lot of PV panels. They are working on requalification of some buildings. So their main goals is to decrease CO2 emission with a given budget. So using a holistic approach helps them to compare different solutions and make some analysis. And the goal is, as we want to study infrastructure and what would be the impact of this infrastructure for the city, we have to project to 2020 or 2030. And we run price scenarios, demand evolution scenarios, so in order to project what would be the cost for the citizen and to be able to assess what would be the energy bill given some price scenarios on gas or on fuel. And the last objective is to help to build a database and to develop analytics to help the stakeholders to make analysis and to facilitate consultation between actors and towards citizens. So how we do that? So the first point is to describe the city. So for instance, this is Paris. In red you have all buildings. So we have a map of buildings by age of construction. We have a description of type of consumer. This is a global model, so we don't model every building. We model types of buildings. And given these buildings, we have some load profile depending on the usage and depending on the type of consumer. So, and we are able to generate unused demand profile. We also use some long-term prospective model on demand evolution and price scenarios. For instance, that's some data from RT, the French TSO, on demand evolution for given usage. We also use some price scenarios from World Energy Outlook to study what would be the impact of some price scenarios. Then we model all the energy system, distribution networks, local production, and we use our simulation tool to optimize what, given some investment, what would be the optimal management of the system. For instance, this is an example with for district heating network. You have a lot of different assets for producing heat. So you have for base load, you have incineration plant, you have coal, and for peak, you have oil. You have oil heaters. So to be able to assess what would be the consumption in terms of oil or gas, you have to run some detailed simulation of the optimal management of the system. So, and the final result is what are the impacts in terms of emission, direct emission from the local producers, or indirect emission. If you use some electricity from the grid, there's some CO2 emission associated. And we also try to assess what would be the impact in terms of finance, what would be the energy bill for the different type of consumers, and especially what is the exposition to fuel price. And finally, I will try to answer to the question, what's the added value? So what we noticed, so there's two sides of the question. The side from the public authority is to be able to build a shared vision for the energy city future. So why? Because it's a way to encourage private stakeholders to invest, and it's also important for them to be able to compare what they are doing now with what they are planning to do for 2020. So it's a way to assess if their goals in terms of CO2 emission can be reached. And for private stakeholders, it's a better market vision for this type of reason. And it's also a way to benefit from this common database and to identify source of energy saving, and also to assess return of investment for new energy action. So, so thank you for this presentation. If you have some questions, maybe I was a bit short, but.
So we have time for maybe 2 questions.
Yes.
Is actually the owner of the code or the tool or the selling of tool you spoke about?
The question was, is Artelis owner of the code? So there's many aspects of the question. For the data, we don't use them. We just collect data, and we use open data. And so for the code, we have some tools to do that, to optimize the management of the system. So that's the tool we use for studies for utilities, and for instance, EDF use our tool for Ireland to optimize production plan. So that's the same technology based on that, and we adapt it for cities with some ergonomics and database to simplify the use of the tool. But we are quite open to explain what we do, and it's very close to the typical approach. It's production cost modeling. Maybe. Yes?
I just wondered, do you have any problems with privacy issues in getting this consumer data? Because in the United States, it's impossible to get this.
Yeah. The data is a big issue. And we choose not to use detailed data. We use aggregated data. For instance, it's for district heating. It's a global produced heat for a given district by district, or it's like electricity consumption by transformer. It's aggregated data, so we don't have privacy problems. And
at your level of data, you said the advantages for the individual
Yeah.
the level of some of those advantages that you
Yeah.
identify for the private company or the private.
What I mean.
They need disaggregating stuff.
Yeah.
It sounds like you're ahead, but I just.
Yeah, that's a good point. But what I meant by a private company is not. It's more utilities and energy providers and distribution DSO, and it's not private company in terms of consumers. It's more a global approach for designing what would be the best infrastructure, and it's not. We don't model each consumer, so we can't help big consumer to know. Sorry?
You would not be able to get that data even if you wanted it at that level?
We didn't try to answer the question because that's already a big issue to try to optimize global investment, and there's other tools to do what you ask, and it's not the goal of this project. And is there a question? Yeah.
I could see how this would be really helpful to a lot of jurisdictions who have already completed their climate action plans and who are trying to recheck on its effectiveness. But have you ever used this in America? Because we have particular methodologies that we use, basically energy based on Department of Energy's particular calculator. Have you done that? Does this averaging work well?
No, we didn't. We didn't do it yet. No.
Okay. Thank you.
Thank you.